Hello everyone, welcome back to my computer project. Today went a bit wrong. I tied up my 8-bit adder to the decoder to try and drive that, and it works. I'll show you, I'll turn it on here. So you can see nothing's input at the moment. It displays a 0. If I put a 1 in, you see it switches to a 1. Don't need to show you this, but you can see it, but yeah, so 1 up here is a 1 down there. If I add 1 to it, it'll come out as a 2. And you'll see the carry here and the 1 bit under there. And if I add 1 to 2, it should output a 3. That looks a bit weak, but I can't really see it. Yeah, but there's an issue. When you go up to, say, 4, it just blanks out. And that's... So while these outputs are buffered now, so those are actually working as far as I can tell, and there is actually a 4 being output here. It's just very, very dim. What's happening is I have to go through this with the multimeter and check the voltages, is that when you apply 5 volts to this, it works perfectly. Or, 4.7 volts, something like that. This is slightly lower than that. Let me just double check it again. This one, it's coming out at it's coming out about 4 volts, 3.93 volts. It's about 4 volts. Now, that doesn't sound bad, and it shouldn't be bad, but the problem actually is these gates, the way these gates work, and the outputs on here. So, if I get rid of that 1, so on this first board, so you see it's coming back as a 3. This first output now is 3.6 volts, which isn't a lot. It's not ideal, but it's working just enough. If I put that 3 back, we'll see what the output, because it's going to this second output now, and that is 3.1 volts. So it's slightly less, and that slightly less is just enough to kill it all off. So the problem is that these gates, they're AND gates, I believe. Yeah. So there's VCC on one end, like over here. So this is the gate in question at the moment, the one that's not doing enough. So at the start of it, it's 4 volts. I know you can't see that over here. You see 4 volts. And the second gate input is 4.2 volts. So there's already a voltage drop there. And on the third one, it's 3.1 volts. And that's what you get out here. And this resistor here is actually dragging it to ground. So it might actually be possible to get it a little bit more out of it. So the way this works is I don't think we actually need that to be low. Like, I don't think I ever need to sink current from these. I don't think it ever needs to come out and go out there. So, because these boards are basically useless now, if they're not going to work with that, because of, at 4 volts, that's enough. These are buffered. That's as much as I'm going to get out of them, really, through the resistor and transistors. But what I'm going to try and do is cut that resistor out, because I don't think it needs to be sunk. I don't think I need to sink the current. So at the moment, it's 3.1 volts. If I cut it, it's not going to ground anymore, and all that should be able to come out here. It shouldn't make a difference. It should be a better difference. It should have higher voltage coming out of here, because you're not sinking half of it. I'll leave that on there. Turn this off, and I should have had my cutters ready. Okay, so we're just going to cut this resistor and see what happens. There we go. It's disconnected. If you can see that. Right, I'll turn it back on. Lo and behold, we've got a 4 now. So I'll just go back and test. We get 3. Yep. 3, 4. Let's try this. That's 4 again. I need to take 1 away, don't I, and then put another one. Put a 2 in its place. yeah, 5. So that would be like over 8. So that's going to be actually what I want to test. So yeah, while we're in these numbers, we'll get this back and have a look at the output of that, because it was 3.1 before, and now it's 3.8. That's good. So just having that resistor there was dragging it down 0.7 volts, and that was enough to make it just not work. So I'm going to be cutting out all these resistors. The reason I favour that as a solution, actually, is because I've wire wrapped all these boards now. They're basically, this was meant to be the permanent fixture for it, it's a permanent solution. So I'm just going to cut all these resistors and hope it works that way. Although I might not actually need to do these bottom ones. There's 5 boards here. 4 of them are the actual outputs. The top one, which is the one I just cut, is the like a controller board. It determines which one of these is actually outputting anything. So all these boards have an enable line, and this determines the enable line. So it might just be a matter of having that enable line working, like having a certain voltage, like over 3.5 volts or whatever it was, on these enable lines. So that might be enough. Just this top board might be enough to get it all working. But yeah, as you can see, that solution worked, and I'm happy with that. It's not a great setup. I mean, no, I'll turn this off. So this isn't actually fixed yet. This will be fixed eventually, but there's actually a few more things that need to happen. Firstly, this won't actually be feeding directly into this. This solution would still need to be there. Like this cut solution would still need to be there, because the board that will be feeding into this will be roughly the same method. It will be the same voltage, about 4 volts. So that will be a buffer board. I've built the buffer board now. Well, half the buffer board. I'll be testing that in a second. But yeah, so that will have to be here somewhere, and this will be behind it, and there will actually be more parts of the ALU, not just the adder. So there'll be a control board for it to determine what, because there'll be different things though. Like you'll have logical operations as well, subtraction, which we use these boards, but there'll be some jiggery pokery going on. You'll have and, or, all those logical operations, and you need a control board to determine what output you're actually getting. And that output, when you choose it, will go to the buffer board, and the buffer board will be connected to this directly, I think. Actually, not even directly, because there'll be 8 bits on the buffer, and this only takes in 4 bits. So after that, so you'll have ALU, buffer, and then, or register, sorry, and then you'll have a thing to, I think it's demultiplexer or multiplexer, whatever way around it is. So you'll have 8 inputs or 8 bits, and you want to take 4 of those, put them in here, get an output. Then you want to take the other 4 of those, put them in here, put them out to a second display. So these will all be the same, these 2 things, but there'll be 2 of these. So there'll be like one there, and you'll switch between which one you're actually using. And I just broke this somehow. Oh, there we go. Broken DuPont cable. Yeah, so there's a lot more to do here before this will properly work. I think I would have had to do that solution anyway. So yeah, I'll go onto the buffer now. So this is the 8-bit register we're working on. So this is just the memory half of it. So the idea here is that you have 8 inputs, and when you enable this, it will take whatever they are and store them here. And as long as you've got power and ground, that information will stay there. So it's actually active low, so this is kept high because it uses diodes. So when you're not, and it uses diodes in reverse bias, so you're trying to push current, well, you're not pushing current, but you've got a voltage on that line, like here, on this line here, and when that's low, the current will go through the diode and out, basically bringing whatever's behind it low as well. But when you've got a voltage here, where say this is 5 volts, nothing on here is going to get out. It's going to stay there. It's stuck. It's like whatever you're putting in here is stopping it. So it's active low, so when you take this low, that's when it activates and it will do stuff, hopefully. I think I've got that the right way round. I don't know. I literally just wired all this up and I have not tested it. I was so tempted to just press the on button and see if it works before I started shooting this video, but I didn't. So this could go either way. I've got these all high at the moment, but if this is set up right, it shouldn't matter. I'll just get random data out on here, hopefully. You should see zeros, or it should either be all zeros, all ones, or mix of both. That's all it can be, but it'll be random. Yeah. So you've got power, ground, enable, which will take low, and that should allow that to work. Or is it? I don't know. We will find out. And these are just direct outputs from the memory. These are actually the opposite of what's in memory. So if you put in all ones, this will be all zeros. If you put in all zeros, this will be all ones, because it uses the not version half of the memory. So yeah, the memory is made of 2 cells. I've got a picture of it here, but it's sort of stuck to my wall at the moment. But yeah, you have 2 cells, one here, or 2 transistors, and when this one's line is high, it opens the gate for this one and lets that coming out, so that one is forced low. And you can force out a switch, and that's what we do with diodes. And yeah, you reverse bias them, that stops it. When you take it away, it's fine. Right, not a very good explanation, but I can't be bothered trying to draw this out right now. So I'm going to turn this on and see what we get. Nothing. Okay. That's either because it's getting all this. I can take one of these low. Okay, I didn't change it. Let's take 2 of these low and try to enable it. Now, actually, when I remove it, that will still actually count as high. If I take it low, okay, nothing's happening here. Click on that's ground. Huh. Okay, let's deal with some bits. I know these bits work. These last 2 here. And nothing is happening. Huh. Oh, I haven't even connected the bloody diodes. Sorry, the LEDs, have I? So in case you thought I was lying when I said I hadn't tested this, there's your proof. I need some resistors. Yeah, I hadn't even plugged them in, so how would I have tested it? Right. There's a bunch of 220s in a little net. Right, let's just plug these in, and then we'll test it for real. Hopefully. Let's put that back high, because I think that's the way I should have it. So yeah, I haven't touched this for a while. I built this sort of around Christmas, but yeah, with Christmas and everything, I've sort of been dragged away from this. And I've had a migraine for 2 days in a row, and I've now got a cough. So sorry if I'm sniffling and have a bit of a coarse throat on video, but I really wanted to get this done so I can move on to other bits without having too much content to make up later. Right, let's get these all right. Final one. Right, now, everything I said before, just imagine that just happened now. Ah, so we actually have some random data. Let's just, it might actually have a little bit of capacitance in there, so it stores it for a little while. So as you can see, I just turned it off, turned it on, got a different value. Leave it a minute. It's those same diodes, but this one occasionally flickers on. Now, it's not always random. There is sort of some consistency to it, based on like none of these components are actually perfect. They all have like a tolerance, like 1%, 5%. They can always go in either direction, but those tolerances are the same. They don't change. So say one was more likely to have a voltage drop, slightly more voltage drop than the other. That one would be more likely to have an on state. So yeah, that's why you'll consistently see these. But this one, yeah, there you go. There's 4 now. So yeah, these ones, they're probably more likely to always land on those 2. And these ones, they're probably a lot, like the components are probably a lot closer in similarity to each other. At least that's my understanding of it. It makes sense to me, so I'll believe it. Right, so we're going to try and change all these to 0 now by enabling that. So we'll take this low. Okay, all but one of them worked. What is that? That's the 4th one. Let's see if we take him low. See, that should have already changed. Yeah, okay, I think the 4th one is broken, which is this one up here. So the configuration here is this is 1, 2, 3, 4, 5, 6, 7, 8. That just worked out here to use. I mean, there's a lot of cable here, but that worked out to use the least amount of cable, and it's sort of consistent. So, right, so we know that one doesn't work. That's all right. It's only 1 so far. Let's take them all. Let's take half of them low, and the rest of them high. Okay, that works. What about these ones? Let's take all these high. And we'll have them all high. You know, I am actually... Yeah, see, I don't actually need to put it in low for that, because this actually opens a gate which takes it to ground. So if you don't open that gate, it doesn't go to ground. So just having it disconnected is the same as having it closed. Right, let's take every other one low. Now we know that's not going to work for one of them, but I think it might actually just match up at the moment. Nah, okay. Hold on. What have you done here, mate? What have you done? This one's odd. Okay, what have we got? Was that broken a second ago? Okay, we know that one was janky, I think. Okay, that one is not coming on now. What has changed with you? I don't know. I don't know what's going on now. Green. Yeah, I don't know. That is. Oh no, that's the wrong way round. That is the wrong way round there. What's about that one? The yellow. That yellow is 4, so that is still broken. Okay, so I just had one cable the wrong way around there. There we go. They should both go high now. Okay, well, the memory works other than this one bit here, which is this one. 2, 3, 4, yeah. I don't see anything obvious. I mean, these are all the same, so... Oh no, I have to give it a closer look. There might be something in there, or there might be a slight short. Who knows? I did have a couple shorts with this before, and yeah, obviously it can be quite difficult to find them. But obviously, when I had the short before, I only had actually 2 things working, and the short was actually between their inputs, so that was pretty easy to find. But yeah, so the memory here works, and it outputs the inverted version. Actually, can I do anything with that? Can I? No, literally, that does not work. That one. That could be anything really. But yeah, so you won't actually use this output. This output will actually go to a board on top of this, which is the tri-state buffer board that I haven't made yet, but I plan to make. And what it means, what tri-state means, or what a tri-state buffer is it can be high when it's enabled. It's like a buffer, but it can be enabled or disabled. When it's disabled, it's like there's no connection. It's not connected to the rest of the circuit. So it's basically not there. Nothing can flow in or out. When it's enabled, it's either high or low, and low would sink current. So the reason that's important is because when you have more of these or other things connected to a bus. So a bus is like, it'll be an 8-bit highway basically, and everything's connected to it, or loads of things are connected to it. And a tri-state buffer allows you to say, I want to output data from this register and input it to that register. And you'll do that by enabling and disabling the tri-state buffers on either one of those. Or on this, actually, because this has an enable as well. So if you wanted to input data to a buffer, you would just enable this line. Otherwise, this is always connected to the bus. It doesn't matter what you put into here. It's not gonna save it. But yeah, that's the first half of the register. I will look at that. I'm actually surprised it worked as well as it did. I was expecting more issues because that was literally the first time testing all of these other bits, because I've only previously tested those first two. So the fact that that one's broken, I'm not surprised. I will find out what it is and fix it. And yeah, so because I've been away, well, not away, but I haven't done a video for a bit. I've actually got a ton of posts. Oh yeah, and before I go into that, if you're interested in my project and you want to see more bits of it, like as I'm building it, so not a video, but like the occasional screenshot or comment or diagram. I sometimes do diagrams, and yeah, so I'm uploading them to a Discord server called Janky DIY, and I upload this a lot there, and there's lots of other cool projects there. And some of the things I'm about to open in the post, I got because of people on there telling me about them, and they just seem too cool to pass up. So yeah, I'll go through them. I'll leave a link to the Janky Discord in the description. Check it out. So I don't know what some of these are because I can't remember. It's been so long. And where have my scissors gone? There we go. This one's quite squidgy. Well, let's have a guess. It feels like it's in a packet or something. I don't know. I don't want to cut it. What is it? Oh, okay, never mind. It's not as exciting as I thought it was. Right, so the story behind this. This will be useful in the future, but not so much now. If I can get it out. But yeah, this is basically to... So you know how I use... I haven't got a spare one, but I've got this half-used one. These matrix boards. You can also get boards that are in strips, and to disconnect one of those strips, you would use one of these. It's a strip board cutter, and it will basically just remove the copper, or dig a little hole and remove the copper along that strip. Oh, sorry. Yeah, so I had some strip boards ordered. I ordered like 50 of them, and I got them for a really low price of like £6 because the seller on Amazon mispriced it. And I thought, oh well, I'll try it and see if they honour it. And the package turned up and there was nothing in it. I contacted the guy and I didn't even ask for a refund. I wanted him to fix the problem or find out what happened, and he just gave me a refund. So what I'm thinking is because this is like £45 worth of boards for like £5, and I think they thought, nah, screw this guy. They packaged it and forced it out and basically ripped the whole thing out. That's what I think happened. Is I didn't ask for a refund and they got one. Seems a bit suspicious. But yeah, that might be useful in the future when I actually get some strip boards. But obviously I won't be able to fit as much. It occurred to me afterwards that I wouldn't actually be able to fit as much on a strip board because half the copy would have to be removed, wouldn't it? So, oh god, what's this? Just checking my address is sort of on that one. Okay, here we go. I don't know what this is. This is quite heavy. What could it be? Well, someone said thank you. Oh. Okay. I was expecting them in a box or something, but that's fine. So yeah, these are more standoffs. If you... Like my 8-bit adder, used a lot of these, and I previously had them in a kit. This is the kit I got before, and obviously I used all those ones. Those were the 10mm ones, and this should be 50 more of them. It certainly looks like 50, so I'll just take their word for it. 25 a pack, I think. I'll have to count later. But they... Oh yeah, I can actually compare them to these ones. If they're the right size, that would be good, because they look perfect. Okay, I'm happy with that. So yeah, that means I can stack more of my other boards as small as possible, as tightly as possible, because 10mm is generally just over the height of the components that stick out of the board. So these are handy because they take up the least amount of space. Thank you for your business. Okay, well that's a nice little bit of card though. Right. Okay, this... Oh, wow. This feels like some more perf board. It is. It's some green ones. What did I order these for then? I mean, I must have ordered them for some reason, but I don't remember. Oh no, okay, it's part of a kit. Well, I say a kit. Thing there. Okay, oh, those are nice actually. So let's have a look at these ones. I think I already have some of these. I don't know if these are the same 7x5s. Oh, they are 5x7s or 7x5s, whatever way you want to put it around. Bigger holes on the corners than what I have. That's okay. How many? I'm going to have to recheck my listings because that's a bit crazy. I do like smashing things. There you go. How many of these were there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 of those. And there's 3 of these. I mean, I like these bigger boards. These are nice. These aren't even the biggest you can get as far as I know. So these are, I think they're 10 centimeters by 22 centimeters, I think. The biggest ones I've found are 30 centimeters. And I definitely want to get some of them, just because, I don't know. I don't know why, I just find these boards cool. I don't know why. But yeah, I don't know why I got these. I know why I got those, because I want them. But these small ones, I'm going to have to recheck the listing, because I thought there was like a wider selection or something. I don't know. I don't know why I got those. We'll see. And another one. Hold on, is this actually... Oh, I know what these are. Okay. These are one of the things that was suggested to me to try out. Well, I heard about it on the Janky DIY Discord, and I thought, I've got to get some of them. And I think I actually ended up getting the wrong ones. And I'll explain that when I... Look at that. Look at this packaging. That is... Why? Why, damn it? I've had this before with something. And yeah, these are kind of delicate things. I mean, they're made of glass. They're little vacuums. So yes, you have to protect it, but come on. You know, you could have just put it in a box. It would have been absolutely fine. You know, I'm more likely to do damage to the things just trying to get them out of the wrapping. A knife would have been great. I haven't got a knife for me up here. Oh god, that is ridiculous. I cannot get in. Can we see one of them? Okay, we got one out. Let's just get this one out and have a look through it. Okay, so the things that were suggested to me on Janky DIY Discord were Numatrons, and they're basically like 7-segment LED displays, but they work with I think it's just filaments in a tube, like in a vacuum, I don't even know if they need to be in a vacuum, to be honest, but I think they are. These ones aren't those, though. These use a slightly different system where you have to have like a grid, I believe, and you have to heat up that grid for electrons to pass through it and actually heat up the actual thing that lights up, as far as I know. Something like that. They're not as simple as the ones I was supposed to get. So, yeah, so the reason I got the other ones is because they could run off. The reason I wanted to get the other ones was because they could run off 5 volts, which means I could use them as 7-segment displays on my computer project. And I wouldn't really call them integrated circuits because they have all these outputs and stuff. You know, a normal 7-segment display is sort of like it's a printed circuit. You can see it's printed. So yeah, the idea was to get some of these, and these are really nice. But these ones require 20 volts just to run that grid. Oh gosh, just to run the grid, and I think it's like 12 volts for each segment, something like that. So I'll use these for a different project, I think. Yeah. So those would be cool to play with, but I won't be doing that just yet. I need to get a little bit more confident with stepping up voltages and that sort of thing. But those are really cool. And there's some. Oh yeah. Also, they don't even make these anymore. You have to get these. These are like Soviet era components, which I don't know. I find that quite cool in itself. What is this then? Well, I did say I had a lot of post. It's like 3 weeks worth. Maybe a few things from before that. Okay, these are actually recent. I got these just the other day. Yesterday, I think. So these are more matrix boards, but these are actually really small ones. And these I will use for my computer project. I mean, if I can get them out this package. How did they get them in there? That's what I want to know. Yeah, there we go. Just rip the package. Okay, so these are by Geek Fun. As you can see, they've got the little branding on it. And they're all square. There's 10 of them, and then these nice little square red boards. They're really nice. And they got these little square pads on them as well. I mean, that's neither here nor there for me, but yeah, the idea I wanted to use these for is, as I was talking about with the registers, they'll be connected to a bus. I wanted to use these to create the bus, because you have 15 lines along here. That's enough for 8 lines, which is going to be an 8-bit bus, with a space in between them, which you can just leave it alone or use it for something. And yeah, these sort of work out into a nice grid. So the idea is you have your bus lines going into here, and you can have them connected to like pins, and those pins can be used to easily connect components or modules of the computer to the bus. So you can sort of have them like that. So these could be connected like that, or you can even have them connected sideways. You can have them connected to the grid, and they'll have pins out. And you know, say you had, I'll just use this board as an example. Here's your 8 bits. You can just connect to that without actually having to reorganize anything. It's all there. It's all got. There could be multiple pins on here, so you can, even if you had a stack of something, you could connect them all to the bus quite easily. So that's why I got these, and I think they just look cool. You know, my original plan was to just go with these nice green boards, but then I started using these cheaper brown ones, and I thought, well, if I'm going to have inconsistency in colour, I might as well go crazy with it and have lots of colour. So yeah, got some red ones here, and they will be useful, and they are really nice quality actually. I like them. Right, another one. I might try and open this like a normal human. Hold on, that looks like wire. If this is wire, I'm going to be annoyed, because I literally just bought that the other day because I didn't think I had any ordered. And it turns out I did have some ordered. Wow, okay. I don't know. I even looked it up to see. Before I bought this, I thought, I better just check I haven't already ordered some wire. And obviously I have ordered some wire. There's 1, 2, 3, 4, 5, 6, 7 colours. How much was this? This is 1, 2, 3, 4, 5, 6, 7 colours. This is 240 meters worth of wire in 7 colors. I think that's about, I don't know, like 35 meters each? I don't know. Or 30 meters maybe. I don't know. And this, I don't know what the lengths of this are. I'm going to have to look up what that is online now. Yeah, okay. Well, I'm not complaining. I mean, this is for wire wrapping. Like, this is literally all I have left of the orange stuff I was using. It didn't. I mean, this was only 5 meters when I got it, but it still didn't last very long. So yeah, some more wire. Don't worry, I think this is the last one. Oh, okay. I don't think you saw that. It had my address on it. I don't think you saw that, but I'll check later. Okay, so this is just more transistors. Good old transistors. These actually arrived very quickly. You know, from China over Christmas. These arrived very quickly. That was about a week and a half, maybe. That's ridiculous. But yeah, that's a lot of stuff. Actually, something is missing. I'm just going to have a quick look. Okay, I don't know. There is actually something missing. It's another... Yeah, I don't know. We'll see if it turns up. I'll have a look into what happens. But, yeah. That's my stuff. That's my video for today. My first video of the year. Sorry I've been ill and stuttery and out of breath, but thank you for watching, and I'll see you later.